So welcome to this. This is the Further Maths Support Programme online revision session for AQA Statistics 1. And today we're looking at correlation and regression. So what do we need to do here? Well, we need to be able to calculate and interpret the PMCC, the product moment correlation coefficient. So again, sometimes you'll see it referred to as just PMCC. We need to calculate something called the least squares line of regression, and again, sometimes they cut out the word least squares and just talk about the line of regression, and sometimes they tell you that it's of y on x, just to give you some idea about which way around your variables go. And we also need to calculate residuals, and basically a residual is the difference between what the model says and what the actual value is. So you're given lots and lots and lots of things on the formula sheet, and it looks quite complicated. What you've got to realise is that this thing here and this thing here are just two different ways of expressing the sums of squares of x's. Usually the second one is the easiest one to deal with, but sometimes in an exam you're given the first expression for sxx. So the same is true for syy, and also for your covariant term we've also got the following. So usually you're going to be dealing with the second halves. And again, with this equation here, what I suggest you do is you just learn this bit here. Okay, don't worry so much about all of this. But if I just go back a slide, you're told what sxx, sxy, and syy are. So we might as well just use it. Okay, you're then given some dud information. It's not dud, it's just something you don't need for this syllabus. Don't forget the way AQA works on their formula sheet is they just give you all the information. You have to know which is for your syllabus, your specification. Okay, so we're not talking about Spearman's rank on here at all. So this B here is very, very useful. It's called your regression coefficient, and notice it's also the gradient of your line of best fit, your least squares line of regression of best fit. Okay, so there's quite a lot of information you're given, which is why you're expected to be able to interpret a lot of this as well. So, straight into June 2010 question 1. We've got the weight X and the engine power Y of cars in a random sample of 10 hatchbacks. And that's my data. And what we're asked to do is we're asked to calculate the PMCC. So, to calculate the PMCC of this data, what we need to be able to do is to work out all the bits we need. So, your PMCC is equal to SXY over SXX SYY. So for this information we need 6 values. So we need n, well that's okay, it's 10. We need the sum of x, we need the sum of y, we need the sum of x squared, we need the sum of y squared, and we need the sum of xy. So this isn't too difficult to calculate, and you can do it all on your calculator. So the sum of x is just the sum of all of your data, we know that, so that's going to give me 12510. Your sum of y is going to be 1180 if you add all of those together. Your sum of x squareds, so you square all your x's and then add them together, is 1583580, and the sums of all your y's is going to be 146616, and then your cross terms summed is 1510062. So again, a lot of that can just come from your formula sheet. So now let's calculate each. So SXX is going to be the sum of x squared minus the sum of x all squared on n. Okay, so in this particular case, it's going to be this 1583580 minus 12510 squared over 10. Please notice it's the numerator squared, not the denominator. Okay, so once you've got your 3 values for SXX, SYY, and SXY, so this one turns out to be 185880, you can work out SYY, so SYY is 7376, and you can work out your SXY in the same way using the formulas before, which gives me 33882. So we're now in a position where we can work out R. Okay, so again, it's just getting the right numbers in the right place. Oops, I forgot my square root. There we go. So 33882, all divided by the square root of, doesn't really matter which way around these go, so 185880 times 7376 and that's going to give me my PMCC 0.915. Now again, it is possible to do everything on your calculator and just come up with 0.915, sorry, and clearly we have to give you the mark for that. Okay, if it was a show that question and you needed to get to this point, then it wouldn't be good enough on a calculator. Okay, so you can appreciate here there's a lot of work to do for the 3 marks, so this is why it's a good idea to learn how to use your calculator to do these. Okay, so how do you get your marks? Well, you're going to get a method mark for attempting some either SXX, SYY and SXY. You need to attempt all 3 to trigger your method mark. Or, I need all of these summatives, so either way, I need either this information or this information to get the first M1. You get your second M1 for using the formula correctly, and then your final accuracy mark for getting the correct answer. Okay, so we're then asked to interpret the value. So what we mean by interpret is you must make sure that you are contextualizing, you're putting it back into the original, and that's to get your 2 marks. So your first mark is the obvious. So here 0.915 was my value of R. That's a very strong positive correlation. Okay, so that will get you 1 mark. So very strong positive correlation. Okay, that will get you 1 mark. To get the second mark, we need some context. Okay, so between your variables. So it's between weight, that's one of your variables, and the other one is power. Ideally we want weight of the car, I guess, and engine power. Okay, so again, full contextualization will help you get that mark there. Okay, so our next question is January 2011, question 5. And similar idea, we've got 11 pieces of data, which is quite nice. And what have we got to do here? Craig uses his car to travel regularly from his home to the area hospital for treatment. He leaves home X minutes after 7:30 AM and then takes Y minutes to arrive at the hospital. Okay, so there's my data. Explain why the time is the response variable. Okay, so the response variable is what you would end up plotting on your y-axis. So to answer that, what we need to just state is that it's dependent, it's your dependent variable. Now you can't just write it's your dependent variable. So what we need to emphasize is what's really going on. So we need to emphasize that time taken is dependent on leaving time. So we can't just say it's independent, or it's the response variable, or it's the independent variable, is dependent on leaving time. We need to say that rather than just time is independent, or dependent, okay? So that's where your 1 mark comes from here. So B is worth 5 marks. Calculate the equation for the least squares regression line. Okay, so first of all we need to work out B, the regression coefficient. So this is going to be SXY on. Now, it tells you it's Y on X. So the denominator must be SXX. Always pick on the thing that's on the second in the expression. Okay, so we've got to work these out. And again, you can just type these into your calculator and get a lot of the values that you require. So to do this, again, we need to have calculated sum of x squared, sum of xy, and n. N is 11. If you add up all of your data, that's going to give me 275. If you add up all your squared data, that's going to give me 9625. You need to add up your y data as well, so the sum of y is going to be 682, and the sum of xy is going to be 20575. Okay, we don't need sum of y squared for this. So these can now be worked out. Okay, so SXY, if you calculate SXY using the same technique we had before, we're going to get 3525. likewise, if you calculate SXX using the technique we've used previously, we're going to get 2750. So that's going to lead me to a value of B of 1.28. Okay, so now we know our model looks like y is equal to A plus 1.28b, x, sorry. So what we now need to find is what A is. So we need to understand that I must pass through. Your line of regression always passes through your mean point. So we can use that to help us out here. Okay, so we know that y bar must equal A plus 1.28 x bar. So I'm going to substitute y bar. Don't forget y bar will be the sum of y over n. X bar will be the sum of x over n. So y bar is going to be 682 over 11 is equal to A plus 1.28 times by sum of x, 275 over 11. A little bit of rearrangement leads us to state that A must be 29.95. Okay, which is 30.0. Don't forget 3 significant figures, we need that extra 0. So what can we say? Well, we can now say that y is equal to 30.0 plus 1.28x. So let's look at where these 5 marks are allocated, shall we? So with this one, you're going to get 2 marks for working out your gradient. Now, if you do it on a calculator, these are called B marks. Otherwise, how are they allocated? So what we need to be aware of is how your method marks and things work through. So you're going to get a method mark for your summatives, very similar to the previous question. You're then going to get another method mark for a correct equation for working out B. You're then going to get an accuracy mark for getting the correct value of B. You then get another method mark for substituting x bar y bar into a correct formulae, and then you get an accuracy mark for then correctly writing your entire model. Okay, so it's quite a nice question. You get quite a lot of marks for this type. Okay, so on part C, on a particular day, Craig needs to arrive at a hospital's reception desk no later than 9. He leaves home at 7:45. And we're asked to estimate the number of minutes before 9 AM that Craig will arrive at the hospital desk. So this is one where we need to use the model. So the model again was y is equal to 30.0 plus 1.28x. Okay, so we need to realise what's going on. So 745 means that the value of x will equal 15 in this case. Okay, just remember what x is. X is how many minutes after 7:30 he leaves. Okay, so x is definitely 15. So what we can do is we can work out what y should be using our model based on x being 15. So our model predicts that this should be 49.2, there or thereabouts. Okay, and again, you get a massive range of answers here. Okay, so we're then asked to work out what the time is before 9 AM. So we're going to start with 9 AM, and we need to subtract from that 7:45 plus your 49.2. We're doing this in time. Okay, so we can see what's going on. Okay, and again, this is going to give you a value that we can work out. So it's going to give me a value of 25.8. Okay, which is going to give me 26. Okay, so we're going to leave 26 minutes before 9 AM, sorry. Okay, so that's worth 5 marks. So where are your marks? Well, you get 1 mark for recognising that x has to be 15. You get a method mark for substituting it into your model. We get an accuracy mark for working out what the model should predict. We then get a method mark for trying to work out what the model suggests in terms of what time you get there before 9 o'clock, and then 1 mark for your final correct answer. Okay, so we're then asked to use the equation to estimate y when x is 85. So as a reminder, y was equal to 30.0 plus 1.28 times 15 times 85. So if we work that out, that's going to give me a value of about 139. Okay, so that's okay, 1 mark, thank you very much. Part 2, give one statistical and one reason based on the context of the question as to why it might be unrealistic. Okay, so the statistical reason is we're actually doing something called extrapolation, which we're not really allowed to do. Extrapolation, let me go back to my data to show you. Extrapolation means that you are outside of your data set, and we can see that your data set is between 0 and 50. So I've used a value of 85, so we are extrapolating. So we're not really allowed to extrapolate. Okay, so we also now need one reason based on the context of the question. So 85, when x is 85, this implies that we're leaving home. If we think about it, 7:30 plus 85 minutes is going to leave me with 8:55. Okay, or 5 minutes. So it's unlikely to be realistic because it implies that he's going to leave home at 8:55 and he's supposed to be there by 9 o'clock, so that's not really going to happen. Okay, so a sort of context-based one would be that.